Okay, in this lesson we will continue to review our trigonometric functions, tangent, sine, and cosine, and specifically we're going to spend some time learning how to use tangent, sine, and cosine to find unknown angles. But first, let's just remember the definitions. Alright, the definitions of the trig functions are often abbreviated this way. In these formulas, theta represents an angle inside of a right triangle. So the sine of the angle is going to be the opposite leg over the hypotenuse. The cosine of the angle will be the adjacent leg over the hypotenuse. And the tangent of an angle will be the opposite leg over the adjacent leg. Okay, so if we're given a right triangle, we could set up these definitions. Alright, number one says the sine of angle A. Remember that the sine of an angle is the opposite leg over the hypotenuse. Okay, so if I look at angle A, which is right here, alright, of course 17 is the hypotenuse. Alright, that's across from the 90 degrees. And 8 is the opposite leg. So opposite leg over the hypotenuse would be 8 over 17. Alright, so that's why the sine of angle A would be 8 over 17. And this is supposed to be matching, so that would actually be, the answer to number one would be A. Look at number two. How about the cosine of angle A? Alright, well, again, here's angle A. Now the cosine is defined as the adjacent leg over the hypotenuse, as you can see right here. So this is the adjacent leg. So adjacent leg over hypotenuse, 15 over 17. Okay, it's all about the angle though. Alright, adjacent means right next to, opposite means across from. So that's why 8 is opposite from angle A, and the 15 is adjacent to angle A. 15 over 17. Alright. Now how about the tangent of angle A? Alright, tangent is defined as the opposite leg over the adjacent leg. So notice we're not dealing with the hypotenuse this time. So I'm just going to erase that for a second. Alright, 17 is hypotenuse, so we don't have to worry about that right now. Looking at angle A, 8 is the opposite leg and 15 is the adjacent leg. So opposite over adjacent, that's 8 over 15. Okay, now things change if we look at a different angle, which I think is what's about to happen here. So for number 4, all of a sudden, now we are being asked about angle B. So we have to change our perspective. Okay, sine of B. So angle B is this angle up here. So for these next few problems, look from this perspective. Now we're supposed to be doing the sine of angle B, and again the sine is defined as the opposite leg over the hypotenuse. Alright, so the opposite leg from angle B, 15 is opposite because it's the one that's across from angle B. 8 is adjacent. So this is the opposite leg, the one that's far away. Okay, and this is the adjacent leg, the one that's closer. And of course, no matter what angle you're looking at, this one is the hypotenuse. Okay, so that's from the perspective of angle B. So with that in mind, the sine of angle B is going to be opposite over hypotenuse, 15 over 17. Alright, the cosine of B, alright, the cosine is defined as the adjacent leg over the hypotenuse. So from angle B, adjacent over hypotenuse is 8 over 17. Alright, and tangent of B. Well, tangent is defined as the opposite leg over the adjacent leg. And from angle B, opposite over adjacent, that's 15 over 8. Okay, and technically this was all matching, so I could have matched those to these answers, but you get it. Alright, now, so for the main part of this video, I want to show you how to use tangent, sine, and cosine to find unknown angles. So here's the key. If you want to find an unknown angle, and you're not given any angles, you're going to need to use inverse trig functions, okay? You will find your inverse trig functions right on your calculator above the normal functions. You see sine, cosine, and tangent, and then above them you see sine with a little -1, cosine with a little -1, and tangent with a little -1. Okay, those are the inverse trig functions. Alright, they can also be called arc sine, arc cosine, and arc tangent. So let me show you how we use them to find angles. Okay, so we're supposed to specifically find the measure of angle A to the nearest tenth. Okay, that's 1 decimal place. Okay, so fine. Here's angle A right here. So this is what you need to focus on in this picture. So from the perspective of angle A, alright, 20. Is this opposite, adjacent, or hypotenuse over here? This 20 is adjacent. See how close it is to angle A? Adjacent means right next to. Alright, see how far away this 30 is? Alright, that is the leg that is opposite. It's the opposite leg. Of course, this is the hypotenuse. So I'm not going to worry about that because I don't have that value. I have the 20 and the 30, so I'm going to focus on those. So I've got opposite and adjacent from angle A. Which trig function does that remind you of? Opposite, adjacent. Well, that's the tangent function. The tangent of the angle is opposite leg over adjacent leg. Tangent function. So let's just write that down. So the first thing you should write down is tangent. And you have to put an angle here. We don't know what the angle is, so we'll just put tangent A equals. Alright? As you saw, tangent is opposite over adjacent. So in this case, that's 30 over 20. Okay, 30 over 20. Now, if you want to find the angle, alright, and you're given sort of this answer, you're given the tangent, you can do the inverse tangent. So that would look like this. We write, okay, the angle is equal to the inverse tangent of 30 over 20. Or I could just put 3 over 2. Alright, but I'm just going to put 30 over 20 for now. And this can just be simply put in the calculator. Alright, inverse tangent of 30 over 20. Or I could just put 3 over 2. Okay, and so to do that we'll hit second tangent, and you see that's inverse tangent. Let me see if I can pull this tighter. Okay, now I forgot what it was. 30 over 20. Okay, so that is 56.3 degrees, rounding to the nearest tenth. Okay, so that would be your answer to number 7. You have to show these two steps and then the answer. You can't just do it all in your calculator and just write the answer. Alright, how about number 8? Again, we're supposed to find the measure of angle A. So you need to focus your eyes on this angle right here. Okay? Now from that angle, okay, we're given these two numbers, 11 and 15. Alright? So, are either one of these the hypotenuse? I sort of like to get that out of the way first. No, the hypotenuse is AC, so that means these are opposite and adjacent. The one that's really close to the angle is the adjacent leg, because adjacent means right next to. And the one that's farther away here is the one that is the opposite leg. So this is just like the last one. We have opposite and adjacent. Alright, opposite over adjacent leg, that's the tangent function. Alright, so I want to see 3 lines of information. The first line should be, alright, we're going to use the tangent function. You always have to say the angle, which is A. We don't know what it is, so we just say A. Tangent of an angle is opposite over adjacent, so that's 15 over 11. You have to write that down. Do not skip this step. So then if I want to know the angle will equal now the inverse trig function. So inverse tangent of 15 over 11. Okay, and this can be put in your calculator. You cannot skip either one of these steps. So then the angle is going to equal, alright, the inverse tangent of 15 over 11. 15 over 11. Alright, so that is 53.7 degrees. Alright, make sure your calculator is in degree mode. Okay, how about number 9? So we're still finding the measure of angle A. Okay, so still focus on that angle right there. Alright, so we've got these two numbers, okay? I've got this number over here that I'm dealing with, and I've got this number right here. Alright, before I just go saying opposite and adjacent, are either one of these the hypotenuse? Yes, the 26 is the hypotenuse. So the 26 doesn't really, the hypotenuse doesn't depend on what angle you're looking at. So I'm not even going to draw that arrow. I'll save the arrows for opposite and adjacent. This is the hypotenuse, no matter what angle you're talking about. Now how about this 14? Alright, from angle A, is this the leg that is opposite or adjacent? This is the opposite leg. Look how far away it is. It's across from angle A. That's opposite. Adjacent would be close right here. Okay, which trig function is this? Opposite, hypotenuse. Sine of an angle is opposite leg over hypotenuse. So I want to see 3 things written down. I want to see sine of the angle, which we'll just call A, opposite over hypotenuse, so that's 14 over 26. Do not skip this step. But we want the angle. Fine, the angle will equal the inverse sine of 14 over 26. Now we could have reduced this to 7 over 13. But then you can just go ahead and put this in your calculator and get the answer. So the angle will equal the inverse sine, so we'll do second sine of, what was it, 14 over 26. I have no memory. Alright, so that is 32.6 degrees. Got to round up. Okay, so we found angle A once again. Do we have any more of these? Alright, let's do a few more. Now that I've done a few, I'm going to start to move faster. Alright, let's just do 3 more of these. Okay, let's keep finding angle A. Now, are either one of these the hypotenuse? Yeah, 16 is the hypotenuse. Let's always get that out of the way first. Now, that means this 10 must be a leg. Okay, from angle A, is this opposite leg or adjacent leg? Yeah, this one's adjacent. Adjacent means right next to. Look how close it is. So we've got the adjacent leg and the hypotenuse. Which trig function is that? Alright, that's your cosine function. So the first thing I want to see is cosine of angle A is adjacent over hypotenuse, so 10 over 16. Okay, that means angle A will equal the inverse cosine or arc cosine of 10 over 16. I'm going to go ahead and just reduce this down to 5 over 8. Alright, just because I can. Alright, and sometimes that's convenient. And then, and only then, can you go ahead and write the final answer. So, angle A, inverse cosine 5/8. So, second cosine 5 over 8. So that is 51.3 degrees. Okay, two more. Look at number 11. Once again, we're still finding the measure of angle A. So, before we go any further, are either of these the hypotenuse? Sure, the 11 is the hypotenuse. Okay, now how about the 7? Alright, from angle A, is this opposite over, is this the opposite leg or is it the adjacent leg? This is the opposite leg. Alright, look how far away it is. Adjacent would be right here. So we've got the opposite leg and the hypotenuse. Which function is that? That's your sine function. Okay, so I want to see three things on your paper. I want to see the setup. Sine of angle A, opposite over hypotenuse, so 7 over 11. Do not skip that step. Alright, then that means angle A will equal the inverse sine of 7 over 11. Do not skip that either. Then you can go ahead and write down the answer. Angle A equals, and you can put this in your calculator, inverse sine of 7/11. So I'll hit second sine 7 over 11. So that's 39.5 degrees. Okay, last one, number 12. Alright, according to the directions, we are always finding angle A for now. So, one more time. Are either one of these numbers that were given the hypotenuse? Sure, this 22 is the hypotenuse. Okay, now this 9 then. Is this the opposite leg or the adjacent leg? This is the adjacent leg. Look how close it is. The opposite leg would be way over here. So we're given the adjacent leg and the hypotenuse. Which trig function is that? That's the cosine function. Okay, so I need to see three things on your paper. I need to see the setup. Cosine of angle A, that's adjacent over hypotenuse, so that's going to be 9 over 22. So then I can say, okay, angle A will equal the inverse cosine of 9 over 22. And then you can go ahead and write the answer. Okay, I want to see 1, 2, 3 things. The setup, the inverse, the answer. Do not skip any of these three things. Alright, inverse cosine of 9 over 22, right? So that is 65.9 degrees. Got to round up. Alright, so that is how you use tangent, sine, and cosine to find unknown angles when you don't have any. Okay, that's going to do it for this video, but there's more to come. Let's take a sneak peek at what's coming. Alright, we're going to go ahead into solving right triangles in the next video. And when we say solve, it just means find any missing angles and any missing sides of the right triangle. So that is what the next video will be about, and I will see you on the next video.